Okay, I'll put this here. Okay, yeah, so for this week, we're going to be talking about Numpy. Some people call it Numpy or Numpy. So after our previous classes on Python, introducing Python generally, it's about time that we start talking about the different Python modules that we will find so useful in data analysis. So the first one of it is going to be Numpy, and after Numpy, we're going to move to pandas, and we talk about matplotlib for plotting and data visualization. So far, this is I'm still going to modify the content, but I'm going to look at Numpy. We're going to look at how we can create arrays, Numpy arrays. And then we're going to talk about array dimensions and how we can index arrays and slicing, and then talk about NumPy data type. So NumPy is a Python library for working with arrays. You remember in previous classes that we talk about lists, which is a traditional Python data type for working with arrays as well, right? For creating list of elements. But the issue is that list is slow somehow, and it has limit to the number of operations or analysis we can perform on them. So it's going to limit the large data analysis task if we are working with list. So that's why NumPy gives us the opportunity to create an array that is faster than Python list, right? Most of the NumPy structure is built on C++, C++, so it is very faster. The array object is called ND array. That's the object for NumPy.
Okay.
Also, NumPy has powerful data structures that guarantee efficient calculations with matrices and arrays. So when we start seeing big dimension, large dimensional matrices, it becomes very vital to use NumPy. And also we have with NumPy, we have a lot of functions. It allows us to perform a lot of operations, functions, manipulation of arrays. Okay. So we can install NumPy, pip install NumPy, we do that. Once we install NumPy, we are ready to import the module. So to do that, import NumPy, and it is a convention to import it as NP. You can import as anything, but the convention is to use NP as alias. Okay, so we have that imported. Right. Then the next thing is to talk about how we create NumPy arrays. How do we create NumPy arrays? So we can create an array from list, right? Remember when we say that we have, let's create a list. So remember how we can create a list, right? Of this is a list, right? If wish, this is showing the values we have, right? To create an array from a list, basically, we're just going to call the array method of Numpy and then pass the list.
Oh,
Yeah. So you see the difference now is
yes.
that we now have array, and we can call this one, let's say this is ARR, and we can show ARR. So this is
Ah,
ARR. So we can check the type. Check array types. You can check the type of each of our the list arrays, and then let's print that, right? Uh, so I want to print this type. For the list, this is the class is list, right?
class is list.
Yeah,
Okay.
the type is list. Then for for the array, you see the type is numpy in the array. Does that make sense? So that's what I was saying here, you know,
Sure.
the array
That makes
objective
sense.
method is called
Mm-hmm.
in the array, okay?
Mm-hmm. Mm-hmm. Mm-hmm.
Also, excuse me, we can
Mm-hmm.
create arrays with we can create an array of evenly spaced values
Mm-hmm.
using a range. np dot. Remember, we have um the range function in Python that
Mm-hmm.
creates a kind of iterables for us, right?
Mm-hmm.
We have similar method, which is arange on NumPy, and then you can say we want between 1 and 10. It will start from 1, but not including 10. So it will create arrays of 1, 2, 3, 4,
Oh,
5, 6.
interesting. Okay.
Yeah, this is almost similar to, you know, like if we want to create um range. So this is create a list, a range of values for us. We can now like put it in a list. Um, you can make that a list. Okay. List.
List range.
Range 1 to
Mm.
10. How do I turn that to a list? I think yeah. Anyways, we can iterate. We can say
Can we do
print
range of the list? Okay.
for I
And range.
in range,
Okay.
right. Then first let's create a list, an empty list. Yeah.
Mm-hmm.
Right. List dot append hi. So
Mm-hmm.
then you can now show our list. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, which is from this range. So this is similar, but the difference between this is that this is a list created
Mm-hmm.
from range. This is
Mm-hmm.
an arrays and NumPy arrays created from a range.
Interesting. And it just created that, and so it's much more direct, I guess.
Yeah,
Okay.
it is.
Huh.
Okay, so we can also create arrays of like the good thing about this is that if we know like I want an arrays between starting from this number and ending on this number, right? We can create that. And also we can also specify the step, right? Let's say we want to step by 2. instead of 1, 2, 3, it will start counting 1, 3, 5, and so we can
Oh,
specify the
okay.
step that we
Mhm.
want. So this is good for like creating like evenly spaced values. It can be like the space is 1 or 2 or something, whatever we
Mhm.
want.
Mhm.
You can read more about that. I mean, on how that works from NP dot orange. All right, so this is a documentation, and it is very detailed. This is
So why would you use it? Like, what do you see the effectiveness of the arrange? How have you used it that it makes sense?
like, are you saying with respect to range or?
Arrange. Hmm.
Oh, yeah. So, like I said before, um, you could see like when we move further, you see like with NumPy, the kind of analysis. No, NumPy gives us more functionalities, more tools to work with arrays. Besides
Hmm.
that, the speed with which we can analyze the data, the
Hmm.
array, is faster. It also
Hmm.
gives us more functionalities that we can use to manipulate arrays, right?
Hmm.
So this is like if we are dealing with maybe just list of 20 values, 20 elements, right? And all we want to do is just like print the elements in the list or just do some minor list um or data manipulation. It's okay, we can use list, right? But when we start moving into data analysis, machine learning, that we are having many rows of values and many columns that we're going to turn to arrays, and then we'll be doing some like machine learning modeling stuffs, right? It will be so difficult if we're using lists. We cannot even use lists because there's limits to what we can do with a list, right?
Hmm.
So
Hmm.
this is why um NumPy comes in, and we're just starting like showing how to like create these simple NumPy arrays, and I try to like make you see how they are similar to a list, and then from
Hmm.
there
Hmm.
we'll build upon that and see how um they offer more functionalities, right?
Hmm. Okay, I understand what you're saying, but and I guess my only question was, how have you used it that you found it to be effective in your own like personal work that you're
Hmm.
doing, like in your research, things
Yep.
like that?
Yeah. So and that's a very good question. Because I work with raster data, like image data, right?
Hmm.
So and we can when you're working with image data, you have a lot of values, like pixel values. You can like have a kind of satellite data that covers, the whole of, not the whole of Idaho, but a very large area, right? And each
Hmm.
of the pixel values are like NumPy arrays, right? They have to be like
Oh.
arrays of values. And you can have a multi-dimensional arrays. You can have like arrays of pixel values, and then one variable is for the temperatures, and then another variable is for like rainfall and all that. So you have like maybe three-dimensional arrays or four-dimensional arrays depending on the data type you're working on. And this is the fundamental data types of
Hmm.
the spatial data analysis. And another thing is that a lot of other most spatial data modules, Python packages build upon NumPy arrays, right?
Hmm. Hmm.
NumPy array is like under the hood of the tools that they use. For instance, when you are using um, real X array, you know, it's a package for cluster data analysis, right? You see, it's built on NumPy and also X array which UX array is using also built on NumPy. So it's a very it's like the fundamental data types for my research, right?
Mm-hmm,
A
mm-hmm,
lot of image
mm-hmm,
analysis, tags and all that. It's a fundamental this thing. And when you are doing machine learning stuff, right, you see that most of the result, especially scikit-learn, right?
mm-hmm,
Scikit-learn, when you do like you fit your model on your training data, and even if your data set, the data you supply into the model are like pandas data frame or pandas series, the results that scikit-learn gives most times are usually like in arrays, NumPy arrays. They usually give the returns in arrays. So
mm-hmm,
array is like it's a very essential data type
mm-hmm,
in data analysis. It's something we
mm-hmm.
cannot do without.
Oh, fascinating. I love that. Mm-hmm.
Hmm.
Yeah. Okay.
Okay, so the next stuff that we'll see, I've shown you how to create a NumPy array from a list, and also how to create a set of evenly spaced values
Mm-hmm.
using a range. We can also use linspace. So this is the syntax of linspace. We call the numpy.linspace. We put the start and the stop. It's similar to a range, but the difference is that um, for a range, we can only like specify the steps, right? Like, okay, we want to get values of number between 1 and 10, right? And the step is 1. That means go increment by 1. That is what we can
Mm-hmm.
do with a range. But with linspace, we can like only specify the numbers that we want between the beginning and the end. So I'm going to demonstrate that. I know that it's a bit um, difficult to understand with words. So now, if I want to like remember this, I generated arrays of number between 1 and 10 that
Mm-hmm.
are evenly
Mm-hmm.
spaced by 2. Now, if I want to use linspace, I'll do np dot linspace 1. It's doing almost the same thing, the same in the sense that the values I'm getting is going to be between 1 and 10, but for linspace, it is not using step. What it is using is that I'm going to give you a value between 1 and 10, and I'm going to make the number of elements in the array to be equals to 50, because by default, number controls the number of elements that we're going to have in the array. So it is 50 by default. So if I do this, you see what I have. I still have values between 1 and 10, but now I have 50 elements in my array. Right, 1, 2, 3. This is 10 by
Mm-hmm.
5. So this is the
Mm-hmm.
difference
Mm-hmm.
between a range and linspace. Does that make sense? So
It
it
does because of the default in lens space. Mm-hmm.
exactly. So we can
Yeah.
change the default linspace to, let's say, I want let's say 1, 2, 1, 2, 3, 4, 5. I want 5. So it gives me values between 1, 10, and 5. I mean, it gives me 5 values
Five
between 1
values.
and 10. Does that make
Yeah.
sense? Okay.
Mm-hmm. It does. Mm-hmm. Mm-hmm.
Now, the very important topic that we'll be talking about next is array dimensions, right? Array dimensions, it refers to the level of array depth. So we are talking about how many, remember when we talk about lists, we talk about list of lists, right?
Mm-hmm.
We can have
Mm-hmm.
a list that contains lists, right? So the same thing happens with dimensions. When we have array dimension, we're talking about how many arrays do we have nested in the arrays and all that. We can have zero dimension, zero the array, and zero dimension arrays are scalars. They are just like single value elements. So we can say we want to create an array of 18. Just put this and put np dot array. This is so let's call this
Hmm.
um array d0. Does that make sense?
Hmm.
Why? This is zero dimension. Why? We can also have um 1D array. Why? Let's say this d1 equals np dot array. So a one-dimensional array is an array that contains like the zero-dimensional arrays elements as its index element. So what it means is that we have like scalar values as the value of the one-dimensional arrays. So this is a one dimension. You can have a two-dimension to the array d2 equals. So what we're going to do here is we can have, so for 2D, we are going to have,
Like a list of lists
yeah, list of
or
lists, right? Exactly.
okay, I see.
So this is going to be one. We can have another one, same value, and we can have another one, same value. So this is going to be array.
Naheem, I have a question. On the
Mm-hmm.
zero dimension array,
Mm-hmm.
we have numpy array dot array 18, and then for me, I would think that that array would be then like 0 to 18, but instead it's just 18. Is that right?
Yeah, so what we're doing is we are just the value we put here is is like the values of the array, right? It's
Mm-hmm.
not like um the dimension. So we say I want an array of just one whose element whose value is one. That means
Mm-hmm.
it's just like saying I just want value 18, just like putting just 18. This is 18. This is a number, right?
Mm-hmm.
So this is not like a list, is a number.
Mm-hmm. Mm-hmm.
So if we want to create a list of values, then we now start saying 18, 17, 16, 15. Now we are bringing more values into the list, right?
Mm-hmm.
This makes
Mm-hmm.
it to be a list. So the same thing, when I put 18 here, right, I'm just like this singular element, this singular value, make it to be um an array. And that's why I say, okay, turn this value into an array. Does that make sense? Or is that confusing?
It does. No, that's great. I just, for some reason, I only thought it never occurred to me that an array could be a single number.
Yeah,
And
I mean, you're right. It doesn't make sense for an array to be a single number most
yeah,
times. It has to be a
okay,
list of lists, right? So it's just
right.
me, because most
Okay.
times when you're working, you hardly see an array just having one element, because in that
Mm-hmm.
sense, the essence of having arrays has not been achieved most times. So
Mm-hmm.
except for
Mm-hmm.
operations whereby they just need the value to be an array, you know.
Mm-hmm.
Anyways,
Mm-hmm.
yeah. Okay.
Great.
So this is a two-dimensional array. So we can like find out like what is the dimension of this array, and ND as which is like the NumPy array data type as ndim attributes that returns an integers of numbers of dimensions.
Mm-hmm.
So if we say, how I run this? Okay, if we say that, remember we're talking about attributes. So if we say, what's this? N number of dimension, ndim. So you can see the
Mm-hmm.
dimension for this is 0. If I change this
Mm-hmm.
to 1, dimension is 1.
Mm-hmm. Mm-hmm.
Does that make sense?
It does. Yes. Yep.
And let's point this to.
Mm-hmm. Mm-hmm.
So we use ndim attribute is going to give us the dimension of the arrays, um, right?
Mm-hmm.
We can also specify the dimension of arrays when we are creating the arrays. For instance, let's say I want to create an array and the arrays. I have a two-dimensional array, array D2. I'll just put that there, right? So I'll just say n dims here is what I'm trying to say is that I'm creating an array from this list, or let me just copy the list to avoid confusion. I'm creating an array from this list, but instead of, if I didn't specify any dimension, it's going to give me the dimension at I put it there, which is going to be 2 dimensions, right? I have list of lists, but I can say I want the dimension to be 5.
Mm-hmm.
Ndim. It's ndim. I don't know why I'm
And
putting
dim.
S.
That's right. And dim. Oh, interesting. It still didn't. That's interesting.
np dot array ndim. Okay, let's see. Hmm. np dot array. Let me check. Hmm. Oh, I'm doing something wrong. Ndim, number of dimension. I'm right. What is going on? Okay, let's see if this is going to work. Huh. Ndim got an unexpected keyword argument array.
It
What's
says
going on?
ndim 0. Is that right? Ndim 0 in the explanation when at the in the web page you were just at?
Oh, okay.
What does that say? Yeah, what is that? Oh, nd min. Nd
Yeah,
min.
that's what I'm putting, right? So this is saying that I want to control the dimension. So by default, it is 0 dimension by
Uh-huh.
default.
Mhm.
But you can control that by modifying the dimension, is what I'm trying to do, but it is not allowing me to do that. It's funny. Just 5. Oh, it works now. I must have been doing something wrong. So,
It was just ndim last time instead of nd min. I think it was
ah,
before. Yeah.
okay, yeah. So
So
that's the thing.
that
So,
makes sense.
so what happened here is that it gives us an array of 5 dimensions. You can
Hmm.
see, we can find the check the number of dimension by
Hmm.
putting dot ND.
D2 and it
So
gives you
this
five.
is
I guess.
5 dimension instead of like 2 dimensions that it was when we created it initially. We changed it to
Hmm.
5 dimension. The point I'm trying to make is that okay, let's do this. We
Oh.
can say that I'm putting a list here. 1, 2, 3, 4, 5 of 10 values. Then I just want it to be in 5 dimensions. So you can see it's still a list, right? But you can see we have like many brackets now, right? Which is like
Mhm.
showing that it's a list that is nested in a list or an array nested in an array or nested in an array or something. Anyways, dimension is a very important concept in NumPy. It's because I tell you one of the errors that people face a lot when working with arrays is dimension incompatibility. You have these dimension issues. This is a particular dimension that I need the data, but you give me the data in this dimension. So it's important to understand the dimension of your arrays and then how to manipulate the dimensions.
Wow, that's fascinating. That's a great explanation. Okay.
Yep.
Yeah.
So we
Mhm.
also have attribute called shape that returns a tuple with each index having the number of corresponding elements. So what I mean is that I can call shape on this array D2 dot shape. So, and it shows that my array is 3 by 5. So you remember D2 is a two-dimensional array, right? Array D2, the dimension is 2, right? So when I call the shape, what shape does is that it returns a tuple where each integer or value is the number of elements in each dimension, right? We have two, D2 is 2 dimension, right? So for the first dimension, we have 3 elements, and which is the first list
Mm.
and the second list and the third list. I think I should print the array here so that I don't scroll up. So you can see this is D2. So we
Mhm.
have a list, another list, and another list. This is
Mhm.
the um um outermost dimension. So and it has 3 values. You can see 1, 2, 3. Does that make sense?
Mhm. Mhm. Mhm.
Then the second value here is talking about the number of elements in each inner dimension, which is 5. So we have 3 by 5. 3 rows. You can think of it as we have 3 rows and 5 columns.
Oh, that's 3 rows and 5 columns. Okay, that makes sense.
Yeah.
X and Y. X
Mm-hmm.
and Y. 3 rows, 5 columns.
Yeah. So, but you can also like change the shape of the arrays, right? The shape attribute is used like gives us the number of elements we have in each index, but we can change it. We can say array D2 dot shape. This is a 3 by 5. We can change it to a 5 by 3. It has 3 rows and 5 columns. Changing it to a 5 by 3 will make it to be 5 rows and 3 columns. Now, you see, we have 1, 2, 3, and we have 1, 2,
Oh,
3, 4,
interesting.
5. 1,
Okay,
2, 3.
okay.
So we have 5 rows and 3 columns.
Uh-huh.
So let's
Hmm.
look at it. But one thing is that you have to be careful about when you are doing a shape is that the the shape you are going to must be able to accommodate the values of the original shape. For instance, the original shape is 3 by 5, which is, meaning that we have in total 15 elements
Mhm.
in the arrays. So if we want to change that to, let's say I want 4 by 3, what do you think will happen?
4 by 3, that it won't make sense.
It won't work
It'll throw an
because
error. Yeah.
it will throw an error because, cannot reshape array of size 15 into shape 4 by 3 because 4
Mhm.
by 3 can only accommodate 12 values, right?
Mhm. Mhm.
So can only do that. So convert, can we try to convert this 1D to 2-dimension? So to do that, we can say, okay, shape, with shape dot, with shape. This is, I guess this is 10. Let me first get the shape. Sorry, I don't know what I'm doing. This is, okay, 12. We have 12 elements.
Mhm.
So I want to reshape that to a 2-dimension, right? I can say, since 12 by 1, I can change it to 6 by 2, right? So this give me 6 rows and 2 columns. I can change it to 4 by 3. 4 by 3. This give me 4 rows and 3 columns.
Mhm.
Yeah,
Mhm.
working with arrays is a bit you know, challenging. You have to build up in your head, but just understand the basis, right? We can also
Mhm.
change this to this. We
Ah,
can
to a
wish,
dimension. Okay. Mhm.
yeah, we can change this to 3-dimension.
Mhm.
We can say that we shape 2 by 2 by 3. That should give us 2 by, so we have like the outer index is, we have 2, right?
Mhm.
And then for each one, we also have another 2, and then we have 3 columns. So this is a 3-dimension array,
That's
right?
interesting. Okay, I can see it getting complicated
Yeah,
quickly.
it's getting complicated. Yeah,
Yeah, yeah.
it's getting complicated.
Mhm.
Yeah, so we can
Mhm.
reshape um the array with, like, we don't know the third dimension, or we don't know maybe the second dimension or the fourth. I know that I want to have 2 dimensions with this particular. I mean, I want to have. I know, for instance, what I'm trying to say is that let's say instead of saying 2 by 2 by 3, I don't know what dimension this 2 would be, but I know that I want the innermost dimension to be 2, and I want the outermost dimension to be 3. So I can
Hmm.
say that, okay, I will just say, copy this, reshape, and here I'll just put -1. So -1 will, like, what I'm telling NumPy is that determine by yourself what the dimension should be. If you know the dimension of 2 out of 3, you should be able to get the third dimension.
Oh, sure. Yeah, yeah.
So we'll get the same
And it does.
value.
And it
Yeah.
does. Hmm.
And one other important this thing that we do with NumPy, our important method with NumPy is the flattening of arrays. When we flatten arrays, what it means is that we have a 2-dimension, we turn it to just a 1-dimension. It's a very important operation in machine learning. For example, when you want to train a machine learning model, the predictor has to be Y values, right? It has to
Hmm.
be values of the target variables. So most times you need to, like, if you have the values in maybe 2 dimensions or something, you have to make it just a series or something. So you can reshape by using reshape -1. So let's say we want to reshape this, remember? Okay, let's say we want to reshape array D2. we want to flatten it. This is a 3 by 5
Hmm.
arrays. If we like we shape -1, it's going to flatten that for us. You can see it turns to a one-dimensional array.
Oh, yeah, sure. That's interesting. Okay.
Yeah, I think there is also flattening method that we can use directly instead of we shape -1. So um this is so far what we have done is look at how we can create arrays and the array dimensions, right?
Mhm.
These are very important concepts that we need to build upon in order to understand NumPy arrays. Yeah, so I think I'll stop here so that we can pick it up on Wednesday. Would if we are able to meet on Wednesday and Friday, we would finish NumPy and then we're going to move to Pandas next week.
Okay, pandas next week. Okay, that
Mm-hmm.
sounds awesome. And thank you so much for your time. What a
Yep.
treat.
Yeah.
But this was neat. The arrays are really kind of cool.
Yeah, it's you see I know that right now it's it's so difficult to really see how all the things we have been learning apply and all that. But when we move into, you know, data analysis
Hmm.
proper or machine learning,
Hmm.
that is when you see the importance of understanding all these foundation topics before we start even talking about, hey, I want to build a machine learning model and I want to do classification or regression tags or so like that, right?
Right.
Otherwise, it will just be like writing codes and you don't understand why I'm doing something I'm doing. So it's
Mhm.
important to take time to understand these foundation topics before we build on to the next, move, would build up gradually to um, the machine learning topics.
And that makes sense. It was like I went out tango dancing with Callie last night, and she's a very good tango dancer, and I don't know how to tango, and I'm learning. But I immediately want to go there and I want to be good. Like I start just with the base, just barely being able to understand it. And I'm just like, I just want to be good at this. I just want to be able to dance, right? And so it really feels similar. Like every little thing, adds up to being able to just have fun with it and
Yep.
just to naturally use it and to think that way. And so yeah,
Hmm.
it's definitely a patient building up to, how it all comes together.
Hmm.
So yeah, no, I definitely understand why we're going through the fundamentals.
Yep. Yeah, it's a building process, and yeah,
Mhm.
everything would make sense eventually. Okay.
Eventually, yeah. All right.
All right. We're going to meet on Wednesday.
Okay. Thank you. I'll see
Have a
you then.
nice night.
You
Bye.
too. Bye.